Have you ever wondered how we can use artificial intelligence to protect elderly people and patients from dangerous falls? Imagine a person falls at home and nobody notices it for several minutes. In some situations, those few minutes can be critical. What if a low-cost AI system could automatically detect the fall and instantly trigger an emergency alert? In today's project, I will show you how I built an AI-powered fault detection system using an ESP32-CAM, MediaPipe post-detection, Python and XIAO ESP32-C3 that automatically activates a buzzer whenever a fall is detected. Let's see it in action. Here you can see the live video stream coming directly from the ESP32-CAM. The AI model continuously tracks the human body posture in real time. As long as the person is standing or sitting normally, the system remains idle. Now watch carefully. When the person falls to the ground, the system immediately analyzes the body angle and recognizes an abnormal posture. A fall detecting warning appears on the screen. If the fall persists for more than 5 seconds, the system automatically sends a command over a Wi-Fi to the XIAO ESP32-C3. The XIAO ESP32-C3 then activates a buzzer to alert nearby people. And when the person stands up again, the alarm automatically turns off. Connect the VCC pin of the buzzer module with 5/4 of the XIAO ESP32-C3. Connect the ground pin to ground. Connect the signal pin of the buzzer module to GPIO pin 2. Make sure to note down this IP address because we will need it later in our Python program. The Python code will use this IP address to send command to the XIAO ESP32-C3, which will then activate the buzzer and generate an emergency alert. Before running the Python code, we need to install the required libraries. Open command prompt on your computer and type the following command. Then press enter and wait for the installation to complete. This single command will install all the libraries needed for our project. Open the Arduino IDE. Go to File, Example, ESP32, Camera Web Server. Choose AI Thinker camera model. Enter your Wi-Fi name and password. Now upload the code. After upload, open the serial monitor. You will get the IP address. As you can see, this IP address is used in the Python code. Now let's understand how this Python code works. First, we import the required libraries. OpenCV is used for video processing. MediaPipe is used for human pose detection. Math is used for angle calculation. And time is used to measure the fall duration. And request allows us to send commands to the XIAO ESP32-C3 over Wi-Fi. Next, we define the IP address of the ESP32-CAM video stream and the IP address of the XIAO ESP32-C3. The Python program connects the ESP32-CAM and receive live video frames. After that, we initialize the MediaPipe pose model, which can detect and track different body landmarks in real time. The calculate body angle function calculates the angle between the shoulder and hip points. These angles help us to determine whether the person is standing upright or laying horizontally. A resizable display window is then created to show the live video stream and detection result. Inside the main loop, the program continuously reads frames from the ESP32-CAM, correct the camera orientation, resize the image and converts it to RGB format for MediaPipe processing. MediaPipe then detects the body landmarks. From the landmarks, we extract the position of the right shoulder and right hip. A line is drawn between these 2 points and the body angle is calculated and displayed on the screen. The fault detection logic is based on this angle. If the body angles become less than 45 degrees or greater than 135 degrees, the system considered it a possible fall. When a fall is detected, a timer starts counting. If the person remains in the fallen position for more than 5 seconds, the program sends a HTTP request to the XIAO ESP32-C3 using the request library. The XIAO ESP32-C3 receives the command and activates the buzzer, creating an emergency alert. If the person stands up again, the program automatically sends another command to turn the buzzer off. Finally, the processed video stream is displayed on the screen, and the program continuously running until the user presses the Q key to quit. This combination of computer vision, artificial intelligence, and IoT enable real-time fault detection and automatic emergency alerts. Now it's time to test the complete AI-powered fault detection system. As you can see, I am sitting normally in front of the camera. The MediaPipe pose detection model is successfully tracking my body and displaying the skeleton in real time. Since there is no fall, the system does not trigger any alarm. Next, I intentionally simulate a fall. As soon as my body becomes horizontal, the system detects the abnormal posture and display fault detected warning on the screen. After continuously remaining in the fallen position for 5 seconds, the Python program sends a command to the XIAO ESP32-C3 and the buzzer turns on successfully. Now when I stand up again, the system recognizes that I am no longer in fallen position and automatically sends another command to the XIAO ESP32-C3 to turn the buzzer off. This confirms that the system can accurately detect both fall and recovery events. To further verify the reliability of this project, I performed another test by falling in a different direction. Once again, the system successfully detected the fall, displayed the warning message, and activated the buzzer after 5 seconds. When I go back up, the buzzer automatically turned off. This shows that the system can detect the falls from multiple orientation. I also tested the system by laying completely flat on the ground. The AI correctly recognized the horizontal body posture and triggered the emergency alert, proving that the fall detection algorithm works effectively, even when the body is fully extended. Finally, I tested the project on my niece. She stood in front of the camera, and the system successfully detected and tracked her body landmarks. When she simulated a fall, the system accurately recognized the event and activated the buzzer after the specified delay. This demonstrates that the project is capable of detecting falls not only for adults but also for children. I hope you enjoyed this project and learned something new from it. Please give this video a thumbs up and share it with your friends and subscribe to the channel for more exciting projects. Thanks for watching and I will see you in the next project.